Okay, good morning, everyone. And first of all, I have to thank Pazzi for doing a wonderful presentation. He said a whole bunch of fantastic things about Dataops as a discipline, which means I don't have to. And it frees me up to talk about a few other things. So I've elected, much like Joe earlier, to change my presentation at the last minute based on a few discussions over the last week. But the first thing I wanted to do was just explain a little bit about who we are and share with you a recent announcement. This will be the first public announcement. This is an exclusive. So Dataops.live are a Dataops platform specifically for Snowflake. We're an elite Snowflake partner, one of the only 18 in the world. And we focus on many of the things that Pazzi talked about, the entire life cycle, both from an operations perspective, so how we ingest data, how we transform data, how we test it, how we enrich it, all the way up to the business user and making sure the business user gets high quality data. We do all the data catalog integration so that, flowing through the system, we have not just the actual real user data, but also the metadata itself. So when a business user comes to a data catalog, they see not just the data, but how fresh it is, what is the quality, ultimately, can I trust it? The key point of, you've got to have trust. And trust is something that, as Pazzi said, is easily lost and hard to earn back. But there's another element to trust, which is assurance. Trust is saying to your business user, "This is good. Trust me." It's okay. The step beyond trust is assurance, saying, "This data is good, and here's how you know why." That's a proactive step. It's actually giving to the user, in line where they're looking at it, information saying, "This is why you can trust this data." So it's kind of trust is the minimum level. But really beyond that, if you go to assurance, it's that's what we see make the huge difference in terms of the uptake of business users for new data products. The other thing we focus on very much is the developer lifecycle and developer experience. Can I just ask one question? I promise it'll be my only hands up question. How many people here either work very closely with software or data engineers or have software and data engineers working for them? Show of hands. Okay, great. That's going to make the second part of this presentation much more relevant. They're our target personas. They're our target users. Our job is to make their life as easy as possible. And going back years, it was about providing, simple development tools. But over the last year, it's been moving very much to dedicated Dataops copilots. And I would say today, probably 70 to 80% of our customers' data products are predominantly generated via AI. And we've got some of our customers are in the room, or ex-customers in the room. To give you an idea, we've got customers who've got over 500 data products in production today, which is amazing by anybody's standards. We started working recently with a large pharmaceutical company who are evaluating what we do, and they said, right, well, the proof of this is going to be a hackathon. So typically it takes us 6 to 9 months to get a data product into production, a complex data product into production. We're going to grab 5 business users with real requirements. We're going to sit each of them with an engineer, and we're going to have a hackathon for 5 days, and we're going to see what we can produce. And after 3 days, everybody went home, which is normally a bad sign at a hackathon. But it turns out after 3 days, they had built 5 data products and got them into production. So this is an organization who historically take 9 months. In 3 days, they built 5 data products, got them in production. Everybody went for a beer and then went home. So that's the sort of quantum change we're talking about in terms of productivity. The biggest problem, I would say, in terms of Dataops in the sphere I operate in is that it can be quite expensive. Our platform at the enterprise level, I'm not going to stand up and say it's a cheap platform. And so the announcement that and it'll go public, I think, or it'll go out in a press release, I think later on today or Monday, is that we've formed a new, very high-level strategic partnership with Snowflake. As part of that, they've made a very large investment in our company. And what that's going to allow us to do is bring key elements of this Dataops capability to the Snowflake customer base free of charge. So rather than an onboarding process and a finance process and a budgeting process and everything else, within, I would say, a month or so, you'll be able to go to the Snowflake marketplace. You'll be able to click on one of these Dataops offerings, and you'll have it in your environment up and running in 2-3 minutes. So that's in terms of accessibility, a huge leap forward, and give a very public thanks to Snowflake for their support on this. But it is only by their support that we're able to bring these offerings to market. And I think the two use cases I want to talk about, because these are the ones that Snowflake brought to us. The first one is enterprise CI/CD. And by that, what I mean is, how do I maintain my entire environment, my entire infrastructure, everything from the lowest level kind of accounts all the way up through the virtual infrastructure, through the roles, everything that goes into it in a very fast, secure, declarative, well-governed way. And what Snowflake provide is some great primitives. They provide some great building blocks, but what they also say is, hey, it's up to you to put that together to make an enterprise platform that suits your needs. And that's kind of what we do. We assemble those for our customers, historically, for very large customers with fairly big checkbooks, but now we're able to bring that free to the market. The second one, and we've already heard them talked about as a migration use case today, DBT, pretty close to a de facto standard in the industry right now. But the difference between a DBT project working on a development server on my laptop and getting something industrialized, operationalized, absolutely bulletproof is pretty significant. And a lot of customers try and solve that today. A lot of customers come to us. We're hoping, alongside Snowflake, that with a free offering into the marketplace, we can make that a complete no-brainer. With 3 clicks, you can import your existing DBT project and have a production pipeline. Not just a production pipeline, but also all of the development workflow that we talked about that goes with it. So create a feature branch environment with a single click. Have the ability for a developer to work in a sandbox in 60 seconds or less, make their changes, go through all of the promotion process, have peer reviews, have 4 eyes on everything. So we're able to do all of the operationalization of DBT workloads, but we're able to do it with the governance that historically only financial institutions, large pharmaceutical companies, and whatever have been able to afford. So that's the announcement I'd like to make. The 2 offerings I talked about, were the first 2. But ultimately we're taking our big enterprise platform that we've been deploying for many years. To give you an idea, 50 million jobs deployed across our customers. They've identified over $100 million in either new revenue or cost savings, but business value. We've got well over 5,000 users. Quite interesting, we did a stat recently. In the last 12 months, we've stopped over 100,000 bad releases. What that means is with all of the automated testing built in, that's 100,000 times a new version of a data product would have got to business users with bad data in it, leading to presumably a bad business decision or an incorrect business decision that we've prevented. So you multiply that up, you work out dollars per mistake, and that on its own is a pretty compelling stat. So we talked about the enterprise CI/CD. We talked about the DBT, enterprise DBT. The other ones I want to talk about, and it came up earlier at the very beginning, was we're seeing this merging of the world of data and applications. They are no longer separate things, and data engineers are starting to become more like software engineers, and software engineers are having to understand more data. These 2 historically very separate worlds are starting to break down. And that's partly because of the moves of the big players like Databricks and Snowflake. Obviously, in my ecosystem, it's predominantly Snowflake who are bringing Snowpark and Streamlit and container services to their ecosystem, basically giving anybody in the Snowflake ecosystem access to not just the full data stack, but pretty much the full application stack as well. And what it means is we need to serve new personas, or we need to take our existing personas, our data engineers, and make it really easy for them. Because these people do not understand building up a Kubernetes cluster or CDK or Terraform infrastructure or anything like that. They might be able to understand Python development, particularly if they're given a bit of an AI assistance. So the other modules that we'll be releasing probably a month or 2 after are all of our builder series. So Native App Builder, SPCS Builder, Streamlit Builder. And they're really designed to cover that middle ground where it's either a developer coming in, a software developer coming in who doesn't really understand data and needs some help, or someone from a data engineering background who doesn't really fully understand software development. Our goal is to make both those personas extremely productive and as productive as each other. So this is just talking, I won't go through all of this, is breaking down a little bit. The chart on the right-hand side, which you almost certainly won't be able to read because I can't read it. There was an analyst firm called ISG, well-respected analyst firm, recently did a state of the market for Dataops. On the right-hand side is the Dataops capability, and incredibly proud that we are the #1 slot there. They rated in 5 different categories. There were only 3 vendors that featured in all 5 categories. Ourselves, IBM, and Informatica. And IBM and Informatica take quite a different view on the world, a little bit less SaaS view. So, very, very proud to see that. But that really kind of shows where we sit in this Dataops capability space. Again, the enterprise CI, I've talked a little bit about this. I won't go into it. And these are our These are our builder models. All of this is browser-based, so there's absolutely no installs required. And the AI behind it, which I'm going to go on and talk about, I would say is really the killer feature. We've been using AI internally, and I was one of the people that kept my hand up to the very end in terms of, is Dataops, so is AI making a positive impact on my business? The answer for us is an absolutely resounding yes. Our job now is to take that resounding success that our own internal teams are getting and bring it to our customers and our users. So that's kind of the company side. The piece I wanted to talk about was about developer productivity, and we've heard a lot this morning about people and process, but nobody's actually talked about the people themselves, the individuals themselves. And that's why I asked the question at the beginning, how many of you either work closely with or manage these people? Because if you want to understand how much AI is taking over from your teams, just ask the question, if all of your team left tomorrow, how productive would you be? And if the answer isn't very, then you still need those people, and they are still very important to you. We announced at the beginning of the year, we did an executive offsite, as most companies do, and we came down with these lofty things, and then we went to our various teams, and I did my engineering and product offsite, and all hands, and I said, we are now fully pivoted to AI first. And I've been, by the way, through history, one of the biggest detractors or one of the biggest skeptics of new things, Web 3.0 and blockchain and crypto and so on and so on and so on. Yeah, I've been very, very slow to adopt new shiny things because of new shiny things. And that whole thing about management saying we need to do AI. Why? Because everyone else is doing it. I see one of my jobs as a CTO is to push back on that and say no. Unless we've got a really good use case, we shouldn't be doing that. AI for me is very fundamentally different, particularly generative AI. It has proven from the very, very first use cases value time after time after time. And yet when we shared this to the company, and my VP of engineering came to me afterwards and said, you really upset some people there. I completely flabbergasted. I mean, how can that not be a fantastic thing? He said, a significant number of the engineers are really worried about their jobs. I was like, this makes no sense to me. I'm making your life easier. I'm taking all of the mundane stuff away. I'm allowing you to focus on all the exciting stuff. And we've got a pretty young, pretty forward-looking, engineering workforce. But there were a lot of scared people. And this started me doing a little bit of research because I wanted to give them some context. And I get asked a lot to forecast the future. My crystal ball, when it was issued to me, was very murky. So I'm kind of like a backwards-looking forecaster. I tried to look at the future by analyzing the past. And so I went back to, before anyone in this room remembers, back in the 1940s, developers used to program literally in binary. Later on in the 40s, assembly language came along. Then we started getting the very first high-level languages, Fortran and COBOL, maybe one or two people. Happily admit this was where I started. Pascal was my first programming language. We started getting the first procedural languages. What happened at every stage of this development was when it came out, everybody was up in arms and said, no, you can't do this. There's no way you can write something in Pascal or C that will be as efficient as I can write it in machine code. Can't be done. Maybe a few toy things here or there, but if we want hardcore performance, we're going to be writing in machine code. How many people write in machine code today? Everyone converted to C. And then Smalltalk and C++ came along. And they said, no. Okay, C++, fine for your little pet projects, but no one's going to write real hardcore applications in C++. You need to write it in C. And then Scala came along. And then Python and PHP came along. And then we moved from just the programming languages to frameworks sitting on top of them. So rather than being a Python developer, I'm now a Django developer, or a Flask developer, or I'm a Ruby on Rails developer. And then we entered the post-Java era with Rust and Golang. And every single time, the same things happened. Everybody's been up in arms and saying, this is not going to work. This is fine for your pet project, but for me, a hardcore person trying to write real software, I've got to use one or two layers underneath. And time after time after time after time, it's been proved wrong. And we're here today. AI-assisted and generative AI-based programming, and I will tell you, this is absolutely nothing different. It is just another layer of abstraction that is going to make people far more productive. And I did this sort of pyramid and I said, okay, well, that's great. As we get wider and wider, I can use that as an analogy for productivity. The problem is, this pyramid gets wider. I get a pyramid, more of a cone than a pyramid, isn't it? This pyramid gets wider linearly. The productivity increases here were not linear. And for those of you in the room who've a lot of people said earlier you've come from a software development background, you'll remember at least the top few of these things and how much more efficient you were. I did some research, and obviously efficiency is a subjective thing, but it looks something like this. Since the very first, since programming in binary or machine code down here to where we are today with high-level languages driven with AI copilots, the research says it's 2,000 to 1. I would say it's 2,000 to 1 over the Pascal development I was doing somewhere here. I think this is probably a significant underestimate. So the productivity has been increasing pretty close to exponential. Now, all I've come across in my research so far is stuff that will support the concerns of my engineers. Like, crap, we're 30 or 40 times more efficient than we were 5 years ago. We're going to need 30 or 40 times less people. That's how a lot of engineers think, even the ones that understand the technology. Because the better they understand the technology, the less they understand the business world and the economics world that goes with it. So what are we to expect from this? It was mentioned a little bit earlier. We've got doom and gloom, if you're an engineer, coming from everywhere. And by the way, I'm talking about software engineers and data engineers pretty much interchangeably here because for the purposes of this, they're under exactly the same, they have exactly the same tools, they have the same opportunities, and they see the same threats. So experts predicting 80% job replacement in the coming years. AI is taking our jobs. Someone mentioned Facebook earlier, AWS saying we've stopped hiring most developers as soon as AI takes over. The one interesting thing, I forget who said it, people saying we're not hiring any mid-level engineers. I've never heard them say, where do the new senior engineers come from if we have no mid-level engineers? AI and a few senior engineers is brilliant, but we don't breed senior engineers other than promoting them from underneath. But this is what the engineers are thinking about, and this is their hypothesis. Development jobs will go down. And in fact, since the productivity is increasing exponentially, it could be even worse. It could be like something like this, an inverse exponential curve where development jobs will drop off to zero. And once I did this research, I realized where the concerns of my engineers were coming from. And I will say, for those of you working with them, whether they admit it or not, there are people in your organization that are thinking about this curve and they are worried about their future. And so the reason I chose to kind of repoint my presentation today was, I was lucky enough that I had this concern bubble up from my teams to me and caused me to do a bit of research on it and wanted to share it with you, hopefully to give you a chance to, first of all, understand that this is happening in your organizations, and then B, to give you some ideas about how to allay it. The real paradox of this, for my first bit of research was on developer efficiency, which is obviously subjective. My second bit of research was on the number of technology jobs or development jobs over that same period. And it looks very, very different. The number of jobs is going up, maybe not quite at the same rate, it's not tracking the exponent, but it's certainly a linear progression. There are twice as many jobs these days as there were 15 years ago. Again, probably more than that. So I would say this is probably, if you want the one graph to take and show your teams who are concerned about this, this is the one that says, look, this developer efficiency is not a threat to you. Now, I noodled on this quite a bit, and I asked a bunch of colleagues and asked around, why do we think this is? Because on the surface of it, it doesn't make sense. We've got a finite amount of work to do. We've got more productive people. Basic algebra says we need less people. What's wrong? What's wrong with that premise? What's wrong with that assumption? I think what's wrong with that premise is we have a finite amount of work to do. Are the people here doing the same jobs as the people here? Absolutely not. We're using technology for far more in 2025 than we were in 1945, or frankly in 2020 or 2015. The incorrect assumption that everyone's making is that the work to be done is a finite, well-defined constant, and therefore more productivity means less people. Actually, what more productivity means is more opportunity. So, and I can speak for this firsthand as a CTO. I look at my team of engineers and say, if they were 10 times more efficient, what could they do tomorrow that they can't do today? And if that's going to have a radical impact on my business, why just have 10? Why not have 20 or 30 or 40? My opportunity increases dramatically. And that's the piece that the engineers don't see, that I understand the business side of things, is with this increase in efficiency, technology is going to move into spaces and solve problems that historically it's never been able to, and that's going to mean more people working much more effectively, but also working on more exciting things. Like, you try and get, I used to work at my previous company, we had a big code base, a big network management system written in Perl. A few smiles of people that remember Perl. You try and get a modern software developer who loves JavaScript to work on Perl. It's just not going to happen. This is absolute legacy. You try and get them writing machine code. It's simply not going to happen. Engineers do not like working on the low-level, boring fundamental bits. They like doing the exciting problem solving at the top. And all this is doing is pushing that problem solving up that stack. Every year they get to work on more and more interesting problems. They get to solve bigger and bigger problems every year, and they spend less and less time working on the mundane things. One thing I will challenge from the session earlier is about quality, because it is a big assumption that somehow AI is producing lower quality code. And I'll challenge that in two ways. First of all, I used to be an engineer. My VP of engineering loves to remind me that I would never be employed by my own company because I wasn't a good engineer. A year ago, I was Copilot writing, and I would fix more of its code. Today, it fixes more of my code. It's come further in a year than I went in 20. In a year's time, it will be writing code that eclipses probably most of the best engineers on my team. So you might say today, yes, it might be true that generative AI is producing code that in a lot of ways is lower quality, and it does really weird things, and it writes stuff it doesn't need to and whatever. But if you look at the rate of change, that is an incredibly temporary thing. In a year's time, we will not be talking about that. So that's the first thing. The second thing is there's a radical difference between what people can do and what people will do. The very first implementation of AI internally in our organization was writing summaries of merge requests. For those who don't know, merge request, you're an engineer, you go off and you do a bunch of work, and then you write a summary of the work that you did for everyone to see, and it gets put into the annals of the company history. I don't remember the last time I saw a human-written merge request that was about more than 6 words. Fixed bug, full stop. Added feature, full stop. Improved, full stop. Why? Because, as we said, people are being asked to do more and more with less and less, and who's got time to sit there and write War and Peace on something it's not functional, it doesn't do anything? Well, actually, it does. Merge requests are there for summaries are there for a very good reason. We implemented something that scanned all the changes and wrote merge request summaries. And the worst AI-generated merge request summary I've seen is better than the best human-generated merge request I've ever seen. And it's not because of people can't do it. If I asked my top developer and said, hey, you've got 4 hours to write a brilliant merge request summary, they would write something incredible. But you're never going to get an engineer to sit down and do that, period. The AI doesn't care. It doesn't get bored. It doesn't see this as mundane work. It doesn't want to get on to the next task. So when people talk about quality, you've got to separate out what people can do and what people do. The other place I'll put this in is unit tests. I have seen more unit tests written in the last 6 months than I have in the previous 6 years. Why? Because someone can sit down and say, right, that was a hard day of developing. I've got 5 minutes before I go home. Write unit tests. And a really good set of unit tests come out. Our test coverage has gone up absolutely dramatically. No engineer likes writing unit tests. And so they do the absolute minimum they can do because they're human beings. They want to get onto the exciting thing. They want to get onto the next thing. AI doesn't care. It doesn't get bored. It writes nearly great unit tests, not great, nearly great unit tests today. Next year it will write great unit tests, and in 2 years' time it will write all but perfect unit tests with 100% code coverage. So when we think about quality and we compare AI engineers to human engineers, I would say in a lot of cases today they are as good or better, and even in the cases where they're not as good, that dynamic is changing. I won't go into this, but if you plot those two things, efficiency against the number of developers, you can argue it's flattening off. I think this is a little bit arbitrary. I actually think this is going to uptick. But even if you extrapolate that out, that is not going to mean, in the lifetime of our current engineers, that is not going to mean anything other than more productivity still means more jobs. It might mean a few less additional jobs, but it's still going to mean more jobs. So what does this bring? So everything I'm talking about here is what I've lived with my teams, and my teams are ultimately a great blend of software engineering and data engineering teams. But what most of you, I imagine, are working with data engineers. What does AI bring to the data engineering world? What I would say is, and this is the way I've described it internally, every one of your engineers today gets promoted to team lead. Now, you may not say that, there may be pay assumptions that come with that, but ultimately everyone gets promoted to team lead. Why? Because historically, I would have had a SQL engineer, and maybe, well, now I need a Python engineer because we're doing loads of stuff with Python. More and more stuff is configuration, declarative driven, so I definitely need someone that knows YAML. And, well, we're living in a cloud world. Who doesn't need a cloud expert and a security expert and, more and more technology native app experts? And this is what a data engineering team kind of used to look like, a really productive one, a state-of-the-art one. Those are all now virtual. Those are all now agents. Our person is now a problem-solving engineer. And anybody that thinks engineers love technology, engineers won't give up this, hasn't spent enough time with engineers. Engineers love solving problems, period. A good engineer will switch technology like they switch underwear. They couldn't care less. That's a tool. It's a means to an end. Engineers love solving problems. And the more experts that they can draw on, the more that they can do, the more different technologies they can use, the better. No engineer likes using the wrong tool for the job. But nobody understands everything. So everybody, to some extent, has to use the tools that they know. What this does is say, look, you can become an expert in everything. Use the best tool and technology for every single part of the problem you're trying to solve, and you will solve it the best way possible. This is the recipe for really, really, really happy engineers. And then you point to the graph and says, by the way, there's an increasing demand for you. People want more of you next year than they do this year, and the same the year after that. Now, in terms of, just timing, in terms of history, there will be a bunch of people that don't make this transition. We've seen that in every time. There are still COBOL programmers today that never moved up the stack. There are still Fortran developers today that never moved up the stack. Irony is they're earning an absolute fortune, but that's a different topic. There will be people that get left behind by this. And you know what? That's okay. We'll still have legacy code bases we need to maintain. There will still be plenty for them to do. But in practice, for the people on your team that embrace this, they are the vanguard of the future. And if they do this well, and they show how they can solve problems using a whole team of virtual engineers, virtual agents, they will be incredibly desirable in the workforce going forward. That's what everyone's going to want to employ. So I think, in short, I would say if you've got engineers, the future is incredibly bright for them. Do not let any of the doom and gloom that you see in the press upset them or knock them off course. They have an incredibly rosy future as long as they're prepared to understand that the tools of their trade will change. The nature of their trade, which is solving interesting problems, will not change. And in fact, what they're going to get to do is more of it, more interesting problems, faster with less grunt work. Now, if I bring it back into my sphere, just to finish up, in terms of Dataops, where do we see AI being deployed? Right now, we're doing a massive amount of work here. As I said, a very, very high percentage of our customers' data products today are being part generated or code-developed with AI. That's why people can turn things around in hours that used to take months. So there's a huge scope on the development side of this. There's also actually a pretty good scope on the monitoring side of this. We did some analysis that said if you just took the output logs of jobs that failed for whatever reason, and you stuck them into a generative AI that had access to our documentation and a few other bits and pieces, like 80% of them, the AI knew what the problem was, which is pretty cool. That's 80% of work off my support team that we don't need to do. But more importantly, if the AI knows what the problem is, why expose it to a customer, wait for them to call in, or wait for them to email and send them an automated response back? If we know what the problem is, as soon as the pipeline fails, why don't we create a branch, fix the problem, send the customer the email saying your pipeline's changed, your pipeline's failed, we fixed it, here's the merge request, review it to make sure you're happy with it, and then commit it. And that's certainly from a software engineering perspective, at the cutting edge, that's where people are today, is when things break, the AI is jumping in, fixing it, getting to the point of showing a merge request. Now, you'd argue, why is it not pushing it all the way into production? And that's the bit where I see we're not quite ready yet. The people still fundamentally want the thing that runs in production, the thing that actually moves and transforms the data my business users are going to see. I want to have eyes on it myself, exactly what it's going to do, before it runs. I do not trust the AI every single time to get it right. So rather than writing a SQL transformation, I could write simply a sentence about what I want to happen. I could check that into my repository, and I have the AI turn that into SQL every time. Why don't we do that? Because they're not deterministic enough yet. They're not reliable enough yet. They still do daft things. They still do a different thing today than they did yesterday. So I see, certainly in most governed industries, people are going to use AI to write all the code, to write all the configuration. They're going to use human beings to check it. They're then going to store that. That's still going to be the definition of their data products. That's what they're going to run in production. And then they're going to use AI to solve problems and address things as they come up. I think this is probably a temporary situation, in the same way that we no longer check the machine code that our C compiler produced to make sure it's good. We just got to the point where we realized, hey, the C compiler is producing great code every time. At some point, we will realize that our AIs are producing great code every single time, and we don't need to go through this step. But I think we are probably still 3-4 years away from that being a reality and every day for businesses. So I will close up, because my time is over, with a picture that one of our principal engineers sent me, given his view on this. This was a few months ago now, but it does kind of describe the change and the move between what developers do. But it doesn't. He sent this, and this was his reason why. This is why I'm not worried about my job. So with that, thank you very much.